Welcome to the deep dive. Today, we're looking at a really interesting way to help large language models get their facts straight.
Yeah, it's all about grounding them in external knowledge,
Hmm.
using Retrieval-Augmented Generation, or RAG.
Right, RG. Now, most RAG systems, they tend to just stick to text, don't they?
They do, typically.
Uh,
Which is fine for some things, but not always ideal.
because if you think about it, sometimes you need text, like, what's the capital of France? Easy.
Sure, text works perfectly there.
But maybe you want to see where a CEO was born? An image might be better.
Or see the Burj Khalifa, you definitely want a picture for that.
And trying to change a bike wheel. Give me a video any day over just reading instructions.
You've hit on a key issue. Real-world questions need real-world information, and that comes in all sorts of formats. Limiting R to just text is, well, limiting.
So that's where this new approach comes in, UniversalRAG.
That's the one.
Uh,
It's designed specifically to pull information from, text, images, and videos.
and not just different types, but different levels of detail, too.
Yes, different granularities. So it can grab a whole document or just a paragraph of full video or just a short clip. Much more flexible.
Okay, so let's dig into UniversalRAG. One challenge I've heard about is this modality gap.
Ah, yes, the modality gap.
If you try to put text, images, video all in one big digital space, they tend to clump together, right? Text near text, images near images.
That's what happens in these unified representation spaces. Even if a text query is conceptually related to an image, the system might just retrieve other text because it's closer in that unified space.
Which kind of defeats the purpose if the best answer is actually in a different format. How does UniversalRAG get around that?
Well, what they do is quite smart, actually. It's called modality-aware routing.
Okay.
Instead of one unified space, they keep separate embedding spaces for each modality. One for text, one for image, one for video.
Like different sections in a library. Textbooks here, photo archives there, film reels over there.
That's a great analogy. And then they have a router module. Think of it as the librarian at the main desk.
Got it.
Based on your query, the router decides which section, which modality is most likely to have the information you need.
Ah, so it sends you to the right department before you start searching.
Right. It avoids those problematic direct comparisons between, say, a text query and an image representation in the same space. It bypasses the modality gap.
And I suppose that makes it easier to add new types of information later, like maybe audio.
Potentially, yes. The architecture seems quite flexible in that regard.
Okay, that handles the different types of information. But you also mentioned different levels of detail, the granularity part. Why is that so important?
Well, think about the questions you ask. Sometimes you need a quick fact. When was this person born? A short text snippet, a paragraph might be perfect.
Makes sense.
But other times you might ask something more complex, like, explain the main arguments in this debate. You probably need a whole document, or maybe several, to get a good answer,
Or for video, you might want to see a specific action, like how to tie a knot.
which would be a short clip. But if you wanted to understand the plot of a movie, you'd need the whole thing.
So UniversalRAG organizes content within each modality at these different levels.
It does. Text is broken down into paragraphs and documents. Video into clips and full videos. Images usually stay as single units.
So the router isn't just picking text, image, or video. It's potentially picking paragraph or document, clip, or video.
That's right. The paper mentions 6 routing categories they used.
What are they?
There's none. For when the LLM likely knows the answer already, no retrieval needed. Then paragraph and document for text, image, and clip and video for video content.
So it routes the query to the most appropriate source, type, and level of detail.
Exactly. The retrieval is tailored based on what the router decides is best for that specific query.
Okay, this router sounds pretty crucial. How does it actually make these decisions? The paper mentioned a couple of ways.
Yes, 2 main approaches for the router design. The first one is training-free, meaning they leverage a powerful, pre-existing large language model, like GPT-4o in their case. They basically give it instructions, a prompt with some examples, and use its built-in knowledge to figure out the best category for a query.
Sort of asking the big model, hey, for this question, should I look in text paragraphs, images, or maybe video clips?
Something like that, yeah. Using its understanding of language and context. The second approach is a trained router.
So building a specific model just for this routing task.
Correct. They train smaller, more specialized models like Distilbert or T5 Large, specifically to classify queries into those 6 categories.
Okay, but wait, how do you train a model like that? You'd need data telling you this query is best answered by a paragraph, this one needs an image, etc. Where does that data come from?
That's a really clever part of their work.
Yeah.
They didn't have perfectly labeled data initially, so they created it by using existing question-answering data sets, or benchmarks.
How did that work?
They looked at the type of benchmark. For instance, some benchmarks test an LLM's internal knowledge. Those queries got labeled none.
Okay.
Standard text QA datasets, where the answer is usually in one spot. They associated those with paragraph. More complex text QA needing info from multiple places. Document.
And I guess image QA benchmarks got labeled image.
You got it. And for video QA, if the questions were about specific moments, they used clip. If it required understanding more of the video, they used video.
Ah, so they used the design of existing benchmarks as a proxy for the ideal modality and granularity.
A very practical way to bootstrap the training data for the router.
Smart. So they built the system, they trained the routers. How did UniversalRAG actually perform when they tested it?
They tested it pretty thoroughly using 8 different benchmarks covering text, image, and video questions.
And the results.
Overall, UniversalRAG came out on top. It consistently did better than systems that only used one modality, like text-only RAG, and also significantly better than baseline systems that tried to use a single unified space for everything.
That comparison to the unified baseline seems key. Does it really show the benefit of avoiding the modality gap?
It strongly suggests it, yes. The modality-aware routing seems to be a major factor in that performance boost.
What about the trained versus the training-free routers? Did the trained ones work better?
In the initial tests on those benchmarks, yes, the trained routers like T5 Large generally outperformed the training-free GPT-4o router.
Suggesting that specific training helps.
It seems so. They also found, unsurprisingly, that the more accurate the router was in picking the right category, the better the overall RAG system performed. Getting the routing right is critical.
And did having those different granularity levels, like paragraph versus document, actually make a difference?
It did. They showed clear improvements on benchmarks like Hotpot QA, which often needs document-level context, and LV-Bench for video when using granularity-aware retrieval compared to simpler approaches.
Okay, performing well on known benchmarks is one thing. But how does it handle completely new types of questions it hasn't seen before? The out-of-domain tests.
That's always the crucial test, isn't it? They evaluated it on 5 new datasets, and the results were quite interesting.
How so?
The training-free router, the one using GPT-4o, actually showed really strong generalization. It performed well on these unseen datasets, sometimes even better than it did on the original ones it was prompted for.
Wow. What about the trained routers?
They didn't fare as well out of domain. They seem to have overfitted a bit to the specific types of questions in the training benchmarks.
So the general knowledge of the big LLM was more adaptable than the specialized training in this case.
For out-of-domain generalization, yes, which led them to propose an ensemble router combining the trained and training-free approaches to try and get the best of both worlds.
Makes sense.
Yeah.
Did they look at model size? Does having a bigger router or a bigger final answer generating model help?
They did. They found that generally larger models used for the router tended to be more accurate at routing.
Okay.
And for the final generation step, using large vision language models, consistently improved UniversalRAG's performance, and it still outperformed the baseline methods across different model sizes. Bigger generally meant better here.
It helps to see concrete examples. Did the paper provide any case studies that really show UniversalRAG in action?
Yes, they had a few good ones. One was a question from WebQA about the color of balloons at a ship launch.
Okay, visual information.
Right. A text-only RAG might find articles about the launch, but miss the balloon color. UniversalRAG's router correctly identified it needed an image and retrieved one showing the balloons, getting the answer right.
What about the granularity aspect?
There was a good example from Hotpot QA, a complex question requiring reasoning across different pieces of information. A system retrieving only paragraphs failed because no single paragraph had all the needed facts.
But UniversalRAG.
UniversalRAG's router chose document. Retrieving the full document gave the model enough context to piece together the answer correctly.
So choosing the right level of text was key.
It was. And a similar thing for video with LV-Bench. A question asked about a specific action in a video.
Like the knot tying example earlier.
Sort of. Retrieving the whole video wasn't very efficient. UniversalRAG routed to clip, retrieved the relevant short segment, and answered accurately. Much better than trying to process the whole thing.
These examples really drive home that it's not just about having access to different data types, but intelligently choosing the right one and the right chunk of it for the specific question.
That's the core takeaway. The dynamic selection based on both modality and granularity, that's the key innovation here.
And the experiments seem to back it up, showing consistent improvements over other methods.
Yes, by tackling that modality gap head-on and allowing for this fine-grained retrieval, it shows a clear path towards RGAG systems that can better handle the, messy, diverse nature of real-world information requests.
So thinking ahead, this capability, this intelligent routing between text, images, video clips, documents, it really makes you wonder how drastically this could change how we all find and process information in the near future.
It does. Imagine asking a complex question and having a system seamlessly pull the best answer, whether it's a paragraph from a report, a specific frame from a security video, or data from a chart image. The potential is huge, though there are still challenges in making these systems truly universal and robust. It certainly pushes us to think about information retrieval in a much more fluid and adaptive way.